Okay, so Spencer, we're going to start with lesson 6.6, which is adding and subtracting mixed numbers. Okay, so a mixed number is just a whole number and a fraction together, right? Mixed as in it's two types of numbers. All right, so the first one we're going to work with is a subtraction problem, and we see they do have two different denominators. So the first thing we need to do is find that common denominator. So to do that, we have a 6 and a 3. So we need to think, the first kind of step to this is looking at your denominators. Ask yourself, will one of them, or is one of them, a factor of the other? Which in this case it is. 3 is a factor of 6. Right? 3 times 2 equals 6. So we can keep 9 5/6 the way it is and change this fraction so that it has a denominator of 6. Okay, let me move that over. And the way we're going to change this fraction to have a denominator of 6 is we're going to multiply the denominator and the numerator both by 2, and we will end up with the same denominator, okay? And why I said you have to do the denominator and the numerator is because whatever you do to one, you have to do to the other, okay? And as I said a minute ago, 3 times 2 equals 6, so that will give you the same denominator, okay? So this mixed number, I am just going to rewrite because we are not changing it. For this one, the 2 stays the same. Your numerator becomes 2. 1 times 2 is 2. And 3 times 2 is 6. Okay, so now they have the same denominator. So I am able to subtract them. Okay, so I'm going to subtract my whole numbers, and then I'm going to subtract my fractions. So 9 minus 2 is 7. And then to subtract fractions, you subtract your numerators, and your denominator stays the same. So 5 minus 2 is 3, and my denominator is 6. Now 3/6 is not in simplest form. It can be simplified beyond that. Remember, when you simplify, it means that the numerator and denominator cannot be divided by the same number again. Okay? In this case, they can both be divided by 3, so that this fraction becomes simplified. So I'm going to divide my numerator by 3, and I'm going to divide my denominator by 3. Okay, so 7 and 3/6 now becomes 7 and 1/2, because 3 divided by 3 is 1, and 6 divided by 3 is 2. So this is my final answer for, take that off, for 9 5/6 minus 2 1/3. Okay. So let's take a look at another one. This one is number 6 from page 267. Okay. We have 10 5/9 minus 9 1/6. Okay, now in this case, again, we have different denominators, so we need to find a common denominator. Now, when you're finding your common denominator, you need to find, like I said, a common multiple of both, but it cannot be smaller than both. Okay? So we're kind of going up from this point. So if we think for the 6, okay, we've got 12, 18, 24, and so on. We could keep going, right? Because 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30. So these are the first 4 multiples of 6. So now let's take a look at 9. It would be 9 times 2 is 18, 9 times 3 is 27, 9 times 4 is 36, 9 times 5 is 45. Well, if we look here, they have a common multiple of 18. Okay, so I'm going to use 18 as my new denominator. Well, in order to get 6 to the 18, I had to multiply by 3. In order to get 9 to 18, I have to multiply by 2. So that means to change this fraction so that it has a denominator of 18, I have to multiply my denominator by 2 and my numerator by 2. Okay? To get 6 to 18, I had to multiply by 3. So I'm going to do 6 times 3 and 1 times 3. Remember, whatever you do to the denominator, you have to do to the numerator. So now I'm going to rewrite these. My whole number stays the same. 5 times 2 is 10. 9 times 2 is 18. Again, my whole number stays the same. 1 times 3 is 3. 6 times 3 is 18. They now have the same denominator, so I can subtract them. I'm going to subtract my whole numbers. 10 minus 9 is 1. Subtract my numerators. 10 minus 3 is 7. My denominator stays the same. Okay? And 7/18 is in simplest form because there is no number that can be divided into both of these that is the same. Okay, so this is the final answer for number 6. Okay, so now looking at one where we need to add, you're going to do the same thing to find the common denominators. You're just obviously going to add when you get to that step instead of subtract. So let's take a look at number 9. We have 3 and 4/9 plus 3 and 1/2. Okay, so again, my denominators are different, so I need to find a common denominator. Let's take a look at 9. Remember, we've done this up here. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. 9 times 5 is 45. I could keep going. I'm going to stop for the moment because hopefully there's one in this set that will work. So now let's find it for 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. 2 times 6 is 12. 2 times 7 is 14. 2 times 8 is 16. Haven't found one yet. 2 times 9 is 18. Oh, look, there's a common one. Okay, so my common denominator is going to be 18. So in order to get 9 to 18, we had to multiply by 2. In order to get 2 to 18, we had to multiply by 9. Okay, so that means these are going to get multiplied by 2, and these are going to get multiplied by 9. Okay, so now I'm going to rewrite them so they have a common denominator. My whole number stays the same. 4 times 2 is 8. 9 times 2 is 18. Plus, my whole number stays the same. 1 times 9 is 9. 2 times 9 is 18. So now my denominators are the same, so I'm able to add. Whole numbers first. 3 plus 3 is 6. 8 plus 9 is 17. And my denominator is 18. Okay, and again, 17/18 is in simplest form. There is no number that can be divided into both of those that is the same. So that is your answer. Okay, so I had told you when we talked, there were a few different ways you could kind of find your common denominator. What I've done here by listing the products and then finding what the other factor was, that's one way to find them. Another way to find a common denominator is to look back at your original denominators and just multiply them together. It may not be the smallest number you could use, but it will certainly work. Okay? So if we look back at number 6, our original numbers were 10 and 5/9 minus 9 and 1/6. I could multiply the 9 and the 6 together to get my new common denominator. Remember, common just means that it's the same. So I could do these multiplied by 6 and these multiplied by 9, and I would get my common denominator. I would have 10 and, 30 54ths minus 9 and 9 54ths. I have a common denominator, so I can subtract at this point. 10 minus 9 is 1. 30 minus 9 is 21. And then my denominator would be 54. And then I can simplify both of these because it is not in its simplest form. Okay, I can divide both of these by 3 to get them in simplest terms, which would then be 1, right, my whole number. 21 divided by 3 is 7, and 54 divided by 3 is 18. Okay, so as you see here, I'm getting the same answer regardless of how I find my common denominator. This case I used 18, this case I used 54, but in the end you get the same answer. Okay, so you can either list them and find the smallest common denominator, or you can just multiply them together to get your common denominator. That would work again for addition as well. Another way you could do this is by changing them to improper fractions. Okay, so if I was going to change them to improper fractions, you would still need to find a common denominator, but it's just another way to find the answers. So using the same numbers from number 5, so we have 9 and 5/6 minus 2 and 1/3. If I wanted to change these into improper fractions, we're going to multiply your denominator by the whole number and then add your numerator. So 6 times 9 is 54, plus 5 is 59, so it'd be 59/6 minus 3 times 2 is 6, plus 1 is 7, so that would be 7/3. But again, I still have to have a common denominator. I'm just going to sneak back up here. Remember, we found that our common denominator was 6, so I have to multiply this side by 2. It's the same for down here. I'm going to keep this one as is. So 59/6. I'm going to multiply both of these by 2 so that I have a common denominator. 7 times 2 is 14. 3 times 2 is 6. And then we would just subtract from here. Let's see, 9 minus 4 is 5. 5 minus 1 is 4. So we would have 45/6. This is improper, so we have to turn it back into a mixed number. Okay. 6 goes into 45 7 times. 6 times 7 is 42, so I'm going to subtract 42 from this numerator. 45 minus 42 is 3. My denominator stays the same. I need to put this in simplest terms, so I'm going to divide both by 3, and I get 7 and 1/2, which if we look back, our answer was 7 and 1/2. So either way you do it, whether you keep them as mixed numbers or change them to improper fractions, you still get the same answer. You just need to remember you have to find common denominators. All right, and then for lesson 6.7, which was 19.2, you are subtracting with renaming. Yes, subtracting with renaming. So again, we're following the same concepts we saw in the last lesson. You have to find common denominators in order to subtract fractions. You can either keep them as mixed numbers, or you can change them to improper fractions. That choice is yours. The lesson shows you both ways to do it, so I will kind of reinforce that and again show you both ways to do it. The renaming part that you see in the lesson title, you can think of this as regrouping. Okay, remember when we were subtracting 2 and 3-digit numbers and you are not able to subtract, say, the ones column, so you have to regroup from the tens. Essentially, you are borrowing them, you're renaming them and putting them in a different column. Let's say we have 49, no, let's change that. 42 minus 9, right? We cannot do 2 minus 9, so we have to regroup from here. We now have 3 groups of 10 instead of 4. We turn that one group of 10 into 10 ones and add it to the 2, so now we have 12 ones, right? We have regrouped, or we've renamed this ones column. That's what you're doing today, or for this lesson. Okay, so the first way I'll show you is keeping them as mixed numbers, finding common denominators. We are going to have to rename or regroup and then subtract. Okay, so I'm going to look at my denominators. I have a 2 and a 6. Well, I know I can do 2 times 3 and get 6, so I'm going to keep this one the way it is and multiply these by 3. So now I have 2 and 3/6 minus 1 and 5/6. Okay, so now that I have the same denominator, I see that I cannot subtract these because I cannot take 5 away from 3. So I need to make my 3 a larger numerator. Now in order to do that, I'm going to have to rename this fraction or regroup this fraction. Okay? Now a fraction that is equal to 1 is the same number in the numerator and the denominator. So right now we're working with 6 as our denominator. So 6/6 is equal to 1. So if I break down this 2 into fractions, I could have 6/6 here, which is 1, and 6/6 here, which is 1. So 1 and 1 gives me the 2. Okay? So if I regroup one of these 6/6 and add it to my fraction of 3/6, it will make this numerator larger and I will be able to subtract. Okay, so I'm going to regroup one of these. I'm going to keep one of them here because I only need 1. So this 2 becomes a 1 because I'm only taking one of them. And remember, 6/6 is 1. So now I'm going to add 6/6 to 3/6. Well, 6 plus 3 is 9. And my denominator stays the same when I'm adding fractions. And then I'm going to subtract. That fraction stays the same. So now I'm able to subtract these because I can now take away not 5 from 9. 1 minus 1 is 0, so there's no whole number. 9 minus 5 is 4, and my denominator stays the same. Okay, I can simplify these. They can both be divided by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So that is your final answer. Okay, so that's one way you can do this. By breaking down that whole number, grabbing one of the fractions that's equal to 1 and adding it to that fraction, making your numerator larger, therefore being able to subtract. Okay. Another way you could do this is by using improper fractions, or fractions that are greater than 1. So I'm going to show you how to do that using the same example to show you we end up with the same answer, regardless of which way you do it. Okay? So I'm going to start with the same problem again. I have 2 1/2 minus 1 5/6. Okay? So first I'm going to make them both improper. 2 times 2 is 4, plus 1 is 5. So that becomes 5 halves. Minus 6 times 1 is 6. 6 plus 5 is 11. Minus 11 sixths. Okay, still have to find common denominators. Just like I did before, I'm going to use 6, so I know I have to multiply this by 3. 5 times 3 is 15. 2 times 3 is 6. This fraction stays the same. And now I can just subtract straight across. 15 minus 11 is 4. Denominator stays the same. You're noticing at this point we have the same fraction. Of course, we have to simplify it again by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So we end up with the same answer, regardless of which way you choose to do it. Okay? Both methods are acceptable. Both methods work. You just have to make sure you find that common denominator in order to do it. Okay? So go ahead and work back through your problems for 6.6 and 6.7, working them out on paper so that you have room to write down your steps, and then you can resubmit that for points.